All right, so today we are going to work on level 3 of applications. Of higher order derivatives, level 3. Please make sure you have a calculator and it has that list again. We need that calculator with that list. If it doesn't have a list, make sure that you grab one with one. I don't know, you gotta turn it on and push apps.
Does it have a TikTok?
No. What kind of question is that? Okay, you're in it. All right, good.
Yeah.
Yeah. Okay. All right. So before we move on to the example, we need some formulas that you'll be using on level 3. So vertical motion. We'll be using this a lot, especially in level 3, because you are going to need to create your own equation. Vertical motion is the formula used to calculate the following: height of an object, time of an object in air, it's the heater, the fan in it. No, we can't open the windows. What?
This is too distracting. Yeah, I feel like I'm gonna kill myself.
Can we not make fun of that? I have sent messages about it. I have no idea if they fix it or not, or if they're going to fix it. The velocity of an object. Height, time, velocity. Yeah. We have 2 formulas we're going to use. And don't worry, you don't have to memorize these. On your assessments, I will tell you which ones to use for now. So the formulas you're going to be using are f of x equals negative 16x squared minus vx plus c. I'll tell you what all these coefficients mean in a second. And f of x equals negative 4.9 x squared minus vx, plus vx. This should be plus. Sorry, those should both be plus. Not minus. For the formula, V will stand for initial velocity. Initial velocity. C is the initial height of the object. F of x is the height of the object after x seconds, or I'm sorry, x time, because it could be other things. Am I going too fast?
Yes.
Okay. All right, do you need me to go up more? Or is right there good? Okay. And then X is going to be your time. Yeah. Sorry. Better you can go after him. Like 5 minutes ago.
This is 40.
Yeah, formulas.
It's 4.9 or 49?
4.9.
Oh.
I'll pass these to you in a second, better. Let me know when you guys are done. Done? Alejandro?
Yeah, I just don't know.
None of you do because we haven't.
Wait, I have to think about the formula.
You didn't put the formulas down?
No, I put the measurement on the formula. Are those numbers that you put, are they part of the formula?
Yeah. Those never change. Those numbers, those coefficients right there never change. Okay?
Really?
Everybody else done? Okay. So for level 3, it's going to be different apps of higher order derivatives. For level 3, it's different because you're going to need to find different things. What you're going to need to find, first thing you're going to need to find is find the maximum height the object is in the air. So I'll just wait until you're all done with that so I can explain it more. Is it better with the light on or off? Okay, on or off. Nobody's ever happy. So that's on. That's off. Okay, so let's say that we're kicking a ball. We're kicking a soccer ball. And we kick a soccer ball. Let's say we kick it from 2 feet off the ground. The path the soccer ball takes will look like this. There is a point of the soccer ball that is its maximum height. When we go from the initial height to the maximum height, we see that it is increasing. And then from there, it's decreasing. Sure. So the speed, there's going to be speed here and speed here. When we get to the maximum, when we stop right there, what is the velocity going to be? 0. So at its maximum, the velocity is going to be 0. So you're going to need some things. You're going to need to make sure that you find v of t. Remember, v of t is also... What? It's up to you. I was just trying to explain to you what it means. What is v of t for calculus? Look at your notes from yesterday. Yeah, what is it though? It's velocity, right? But how do you find velocity? Look at your notes from yesterday. How do you find velocity? Anybody remember?
Meters per second?
Nope. That's the units. Yeah, s prime of t. So remember that velocity is the derivative of your original function. And then you're going to have to make sure that you set that equal to 0 and solve. So this is what the calculator is for, but also we'll use some algebra today to solve for it. The other thing you're going to need to know is the time. Hey, David. I think that's the examples for today, but we're taking notes right now. And then can you give this to Bere, and then when she's done with it, she'll pass it to you. The time the ball is in the air at specific heights. We'll talk about that later too. Yeah, okay. And we'll talk about how to solve these in a second. Are there any questions so far before I get to the example? Bere. Bere. Berenice. David, just grab the notes from her. Does everybody have a calculator? Does everybody have a calculator with that list on it? Okay. Did you figure out if your calculator solves? Ready? Okay. All right, let's look at example 1. So example 1 says an object is thrown vertically upward at a point of 15 meters above the ground and initial velocity of 49 meters per second. Use the formula S of t to answer the questions. So the first thing you're going to need to do is to create an equation. Okay. So if I'm looking at this, I notice I have a V and I have a C. If I read the question tells me that the initial velocity is 49 meters per second. So this is going to be V. Are there any questions on that part? Good? Okay. And it says it is thrown from a point 15 meters. That means this is going to be C because that is my initial, what's up? Over here. That's my initial height. That is where we're starting to throw it from. So all I need to do is substitute in these two numbers to get my equation. So S of t is equal to negative 4.9t squared plus 49 t plus 15. Are there questions on that? Good? Gentlemen.
Give me 1 second, please. Let me just figure out how you create all this. She tells you 49. At 49.
49, it says initial velocity, and in your notes I said initial velocity was v. So I just substituted in 49 for v.
Right there at the beginning where it says that he's negative 4.9.
Yeah.
Question, aren't you supposed to put the 16 every time?
No, remember I said there are two formulas. So this one is telling you specifically
okay,
you use that formula.
I see which one. Velocity and what is C? What does C stand for?
C stands for the initial height,
Starting.
the starting height. So the starting height was 15 meters.
Oh, okay, I got it. No more questions.
Okay? All right.
And you can see what pages.
Next thing it says is how many seconds it takes for the object to reach its maximum height. So we need to find the derivative of this because we're looking for velocity. Or we're looking for the time it stops having velocity. So v of t, remember this is going to be the derivative of s of t. Derivative s of t. So that gives me negative 9.8 t plus 49. All I used was the power rule. I multiplied 2 times negative 4.9, gave me 9.8. Subtracted 1 from the exponent. 2 minus 1 is 1. You don't have to write the 1. And because this is a linear term, we just drop the t and it becomes 49. So I need to solve for t. So I'm going to set the velocity equal to 0 because when it's the maximum height, velocity is 0. And I'm just going to use algebra to solve. We don't need the calculator where we had apps in number 9. We don't need the calculator for that, but if you want to use it, go ahead. But this is just simple algebra. I'm going to add 9.8 to both sides because I want a positive exponent for the t. I'm going to finish it over here. That gives me 9.8. Can you see that? No. That gives me 9.8 t plus is equal to 49. Can somebody put that in their calculator? Because I don't have my answer key. I think it's 5 seconds. Yeah, 5. Don't forget to write your sentence. The ball reaches a maximum height or object. In 5 seconds. You will not get full credit on your assessment if you do not include your statement. So please make sure you're including your statement. $5 seconds? This? The object reaches the max height in 5 seconds. Okay. Part C asked me for the maximum height. So we found the time that it reaches its maximum height. We just have not found the actual height. A lot of students will start to put it into this equation. So we're going to need to substitute in 5 into an equation. We cannot put it in this one because this one is for velocity. This is for velocity. This is not height. This is for height. The S of t is for height. So that means we need to take this original function and substitute in 5. So S of 5, negative 4.9 times 5 squared, plus 49 times 5, plus 15. I don't have my answer key. Can somebody put this in the calculator? No.
Oh, I did.
137.5.
137.5? Don't forget to write your little statement. So, yes. The max height of the ball, or the object, it's not a ball, is 137.5 meters. Are there any questions on part C?
Let me just write it down now.
I'm sorry?
Just write it down now.
So that'll be a full sentence, is it then?
Yeah.
You just put, like, summarize it down.
I mean, that's like 8 words. How more summarized are you going to get than that? It's not even 8 words. 1, 2, 3, 4, 5, 6, 7, I guess. No, that's, it has to be like that.
So what's the whole sheet in Congo? What's all that?
I'm sorry?
The whole sheet.
What about it?
How'd you get there and where's the full what's the border?
Where were you like 30 seconds ago when I was explaining this?
I'm focused on trying to copy it down.
Okay, that gives me context. Okay. All right, so you ready? Okay, so we're looking for the maximum height. Velocity, huh?
Is it on my notes? Maximum height, how to find it?
I'm explaining on how to find it right now. You can't use this equation because this gives you velocity. So you have to go back to the original equation because it gives you the height. Okay? Okay, so now, because I know that the maximum height is reached at 5 seconds, because we just found that,
Okay.
I substitute the 5 in for every variable.
Okay.
Okay? When you put that into your calculator, Julian got 137.5.
Ah, I see.
Okay? So that is the maximum height the ball reaches in 5 seconds. Okay? Got it? Okay. Alright, next one. How long does it take to hit the ground? When it hits the ground, what is the height? 0. So I'm going to have to go back to this equation and set it equal to 0. And then you're going to need the calculator for this part. So make sure you have your calculator. All right, somebody tell me what to press. Apps. 9. 1. All right, hold on. Slow down. Hold on. So, David, apps is right here. 9. 1. Okay. Can you guys help Oscar because he wasn't here yesterday? All right. So Jaime said we put 2 in. Keep in mind that we only put 2 in here because it is the highest exponent. If you have a higher exponent, you have to make sure that you're changing it, okay? What do I do now? Hit next. Okay,
Where's the next one?
right here. So you're going to have to hit the one underneath it. Okay. Now, obviously, I have my numbers in here already, but you should be putting your numbers in. If you have the other calculator, the bigger calculator, it's going to be a list. Okay? So after you enter those numbers, what do you push? Graph. Wait, did I do something wrong? I did. This should be plus. Sorry, guys. Okay. Okay, I'm going to zoom in so you can see my calculator. If you notice, I have 2 x values. That means your function, if you graphed it, would cross the x-axis twice at negative 0.297 and at 10.297. Your context of the problem, you have to think about it. These 2 x's stand for time. Can you have a negative time? No, you cannot have a negative time. So the only one that matters is the 10. So you would say the ball hits the ground, or the object hits the ground at 10.3 seconds. Round to the first decimal place. Round to the first decimal place. 10.3. Yeah, 10.3. Questions? Okay, we're going to skip E because I realized that is for quarter 4. On the back, there's one problem. Come get it checked for your credit today. You can work in your groups. And you have 20 minutes. If you want to watch the video from yesterday, grab a Chromebook and watch the video from yesterday. Okay, same for you, Oscar.
Can I fill this to get credit?
Yeah, of course.